Good morning everyone. In the last video we had discussed about the electric field, intensity of electric field, electric line of forces and the distribution of charges. In this video we'll talk about electric dipole and dipole moment. This is the most important part of the chapter. Very often you find numerical questions or derivations coming on this topic only. Even this year we had a 3-mark question coming from this topic. So every alternative year or every year we have one question coming out of this 3 topics that I am going to discuss in this video. Is it clear? So let's start with electric dipoles. What is electric dipole? Electric dipole, when two equal and opposite charges are separated by a distance 2L, it is known as electric dipole. Once again, two equal and opposite charges, minus Q plus Q, separated by a distance 2L, makes an electric dipole. Okay, this is known as electric dipole, or the product of two charges. The product of two charges separated by the product of the charge and the distance between the two charges separating them is known as electric dipole. Now this dipole will also have a dipole moment. This dipole, electric dipole, will also have a dipole moment. Dipole moment is represented by the letter P. Since moment is a vector quantity, so electric dipole moment is also a vector quantity and it is the product of Q and 2L. What is electric dipole moment? It is the product of the charge and the distance separating the two charges. Now dipole moment and electric dipole, these are two different things. Electric dipole is simply the two equal and opposite charges separated by a distance of 2L, and dipole moment is the product of the charge and the distance between the two charges. That is, it is again a vector quantity. The SI unit, it is a vector quantity. When I say it's a vector quantity, then it should have a direction also. So what is the direction of electric dipole moment? The direction of electric dipole moment is from the negative charge to the positive charge. The direction, whenever we are talking about vector quantity, it should have direction. So direction is from the negative to the positive. So this is representing the direction of the electric dipole movement. Is it clear? And when we say negative to positive, it means it is opposite to the electric field. Electric field is always from the positive charge to the negative charge, or away from the positive charge. Whereas the electric dipole moment is from the negative to the positive charge. Then we talk about SI unit. SI unit of electric dipole moment. It is coulomb. Here coulomb, and what is length? Meter. So SI unit is coulomb meter. This is the SI unit of the electric dipole moment. Now when we talk about electric dipole moment in chemistry, you must have studied about the molecules such as HCl. HCl. It is a polar molecule. Why polar molecule? Because the center of the positive charge and the center of the negative charge are not coinciding. They are not at equal distance from each other. So the shared pair of electron is slightly shifted towards the chloride ion and it gets away from the H ion. So H develops a slight positive charge, chlorine develops a slight negative charge, it becomes an electric dipole. So HCl and water, their center of positive and negative charge do not coincide at a point. As a result, they behave like a electric dipole. Is it clear? So HCl and H2 are examples of electric dipole. So next we will discuss electric field due to electric dipole. Electric field due to electric dipole can be in two positions. One is end-on position or axial position. Second one is broadside on position. The broadside on position is perpendicular. The electric field is to be calculated on the perpendicular bisector of the electric dipole. So first one we will discuss end-on position. This is the diagram for the end-on position, that is along the axis or axial position. We have an electric dipole minus q and plus q, and we have to find out the electric field intensity at a point P, which is at a distance r from the center of the electric dipole. This is r, set from the center O. We have to find out the electric field intensity at the point P. Now, since electric dipole is made up of minus q and plus q charge, we know that plus q charge will exert a force in the outward direction. So this is the direction of electric field due to plus q charge, and minus q electric field will be towards the negative charge. So this will be in the opposite charge. Now what do we find? We find that at the point P, the electric field E1 and E2, they are in the opposite direction, and along the same line. So electric field is E1 is along the axis of the dipole outward, E2 is along the axis of the dipole inward towards the dipole. So we will calculate out the now electric field. So E1 is equal to 1 upon 4 pi epsilon naught q upon, what is the distance for the positive charge? R minus L whole square. Okay. Now E2 is equal to 1 upon 4 pi epsilon naught q upon R plus L whole square. The distance R has been taken from the center. So this one distance is L. So from plus q point R minus L whole square, and at the from minus q it is R plus L. Net electric field E net will be the difference of E1 minus E2. E1 minus E2. Why E1 minus E2? Here in this case the denominator is smaller. It is R minus L. So the value will be bigger. Here R plus L. So denominator is bigger. So the value of E2 will be smaller. Therefore E1 minus E2. So net electric field we can calculate 1 upon 4 pi epsilon naught 1 upon R minus L whole square minus 1 upon R plus L whole square. Okay, and on solving we get here 1 upon 4 pi epsilon naught 2RL, that is 4RL upon R square minus L square whole square. Clear? Now further we know that we take here 1 upon 4 pi epsilon naught 2R into 2QL upon R square minus L square whole square. Now what is this 2QL? It is equal to P. So we write here 1 upon 4 pi epsilon naught 2PR upon R square minus L square whole square. We write here, if R is greater than L, then R square will be much greater than L square. So we can ignore L square. So we have 1 upon 4 pi epsilon naught 2PR upon R is to power 4. 4 से R ये cancel हो गया. We get 3. Net electric field is given by the formula 1 upon 4 pi epsilon naught 2p upon R cube. Okay. So this is how. Now this question, if you look at it, we will discuss this in the form of examination. Here 1 mark, this diagram is compulsory in the examination. Out of these two, you need to write these two equations out of which one should be correct. And the third one, this formula 2PR, this is 2QL, it should be done. Then only you will get 3 marks in this question. Okay. The next one is the electric field due to electric dipole in broadside on position. As I had told you earlier, it is also perpendicular bisector of the electric dipole. So we have taken a point at the perpendicular bisector of the electric dipole at a distance r. So we plus q exerts the electric field in the outward direction and minus q exerts the electric field in the towards the negative charge. So we have to find out the electric field. So we make this diagram. Diagram is very important. Diagram minus q plus q separated by distance 2l. The distance of the point P from the center O is r. The direction of the electric field. These arrowheads are very important in examination. Arrowhead in the outward direction. This is towards negatively charged particle. This angle is again theta. This is also theta. Where theta is the angle of inclination of the line. Okay. Now the electric field, this distance, this is right angle triangle. This distance is r, this distance is l. So this distance hypotenuse is under root r square plus l square. So electric field due to plus q charge. Electric field due to plus q charge is E1. E1 is equal to 1 upon 4 pi epsilon q upon under root r square plus l square whole square. Minus q also, the magnitude of the electric field remains the same. It is again 1 upon 4 pi epsilon naught q upon under root r square l square raised to power 2. Here, now, but what is happening? The direction. If you look at the direction, directions are, one is along the direction, this one, and the other one is towards the negative charge. Now, the resultant net electric field will be equal to E1 plus E2. That is equal to net electric field will be equal to E1 cos theta plus E2 cos theta. What is the electric field? Net electric field will be equal to E1 plus E2. That is equal to E1 cos theta plus E2 cos theta. Here we will write cos theta. So this is how we will find out the electric field. So in the triangle, E is equal to E1 cos theta plus E2 cos theta. E1 and E2 both have got the same value except that their directions are different. The numerical values are same. You can see here 1 upon 4 pi epsilon q upon root r square plus s square whole square. Same here 1 upon 4 pi epsilon naught q upon root r square plus l square whole square. So their magnitude values are same but the directions are different. So we have to find out the net electric field. Net electric field is given by this E1 plus E2 cos theta. So we can also write it as E2E cos theta. We consider this as E and E. This again as E. So this becomes 2E cos theta. Now to find out cos theta, in this triangle we have theta here. Cos theta is based upon hypotenuse. So base is L and hypotenuse is r square plus l square. So that is L over r square plus l square raised to power 1 by 2. We substitute the values here. What do we get? E is equal to 2E cos theta. That is 2E cos theta. We put the values here 1 upon 4 pi epsilon naught q upon r square plus l square. And 2 into L upon r square plus l square raised to power 1 by 2. Now, this is 1 upon 4 pi epsilon naught. This multiplied to this gives you 3 by 2 power 3 by 2. What is 2QL? 2QL is dipole movement. 2QL is dipole movement. We substitute the value of dipole movement P here. We get 1 upon 4 pi epsilon naught P upon r square plus l square raised to power 3. Now, if the dipole is very small as compared to the distance of the point at which the electric field is to be calculated, let this distance P be far away from this dipole, then as a result we can, R is very large as compared to L, then R square will be very large. So we can ignore L. So we ignore L, what we will get? We will get R 1 upon 4 pi epsilon naught P upon R cube. What we will get? P upon R cube. Is it clear? Thank you. torque is left on a dipole moment. We'll continue it in the next video. Thank you.